Hello and welcome to our next unit. This is an error. This should say 6.3, Proving Parallelograms. So last time we had a video, we were given a parallelogram and we had 5 different properties that were parts of parallelograms no matter what type of parallelogram it was. Now here we are given a quadrilateral and it is our job to determine, is this a parallelogram or not? So we don't know that it is a parallelogram. It is just a quadrilateral. It's a 4-sided shape. And there are ways to figure that out, right? It's kind of like, how do you determine a square is a square? Well, we definitely need 90-degree angles, but that's not the only defining characteristic. All of the sides have to be congruent. So it's the same thing here. Proving parallelograms, we have certain features of parallelograms that prove a quadrilateral is a parallelogram. So let's jump into it. Hopefully you got the titles down. If, and then I'm going to draw a blank here. And we're going to leave that empty for now because we are going to dive into the ifs. If blank, then the quadrilateral is a parallelogram. The quadrilateral is a parallelogram. All right, so this is where the if is. Now, if any one of these 5 tests to prove parallelograms is true, then it is definitively a parallelogram. So there are 5 tests. 5 tests to prove parallelograms. All right, so the first one, very much like the properties of parallelograms, is both pairs. If both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. 2, if both pairs of opposite sides, just like before, are congruent. So notice right away that these first 2 are, I'm going to put this in red, are exactly like the first 2 we have for properties of parallelograms. Okay? And if you were to guess, yes, this third one is also true. So 3. If both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. So I'm going to put a star next to this one because it's the exact same. Now, number 4 is not the same. Okay, so I'm going to skip that one for now because I'm going to go into greater detail with that. But number 5 here says diagonals bisect each other. And that is actually also true. If we see a quadrilateral where diagonals bisect each other, if diagonals bisect each other, then the quadrilateral is a parallelogram. Now this 4th one, so I'm going to put a star next to that 5th one as well because they completely line up with these as well. These first 3 and this last one. 1, 2, 3, and 5. Number 4 is where it does not work. Consecutive angles are supplementary. Does not prove, well, it doesn't help. But we'll get into that another time. The other way to prove that quadrilateral is a parallelogram is, I'm going to do this in blue, is if one pair of opposite sides are both, and this is important, so both of these have to work, both parallel and congruent. So this is what it will look like. If we have a parallelogram, or if we have a quadrilateral, we don't know it's a parallelogram, but we have one pair of sides. Let's say it's this blue side, okay? And let's say this blue side is both parallel, so it has the arrows, and congruent. So I'm going to put a tick marker and a tick marker. And if it's a little confusing like that, you can put it behind it as well. It doesn't quite matter where it goes. If it's both parallel and congruent, then the quadrilateral is a parallelogram. So this is a parallelogram. Now, it doesn't have to be the top and the bottom. We could also technically have this. If I drew this instead, one side parallel, one pair of opposite sides parallel and congruent, this is also a parallelogram. Where it does get a little bit weird is if you have this case. So I'm going to draw a red line here to kind of mark that differently. And what happens when I have this case? If I have a quadrilateral where one pair of opposite sides are parallel, the other pair of opposite sides are congruent, that does not mean, this can be, but this is not always. So this is not always a parallelogram. You're going to find out later that this could technically be a trapezoid. Okay, so this is not always a parallelogram. It can be, but it's not always. So we cannot definitively say for this particular case. So be mindful of that. It has to be the exact same side pair. Okay, opposite. That's why it says one pair of opposite sides that are both parallel and congruent. Okay, so that's all I have for you today. If any of these criteria fit into this if, then the quadrilateral is for sure a parallelogram. If you do have any questions, please ask, and I will see you in the next one. Bye.